Hello students. So as you know, we have been solving the JEE mains paper of 2017, and in that we have been solving the physics section. This is question number 42 from the question set D, and in this question we have been given a magnetic needle is placed in a magnetic field. Now this needle is performing simple harmonic motion along its mean position due to this magnetic field. So we have been given that the magnetic moment of this needle is nothing but equals to 6.7 into 10 raised to the minus 2 ampere meter square, and the moment of inertia of this needle is equals to 7.5 into 10 raised to the minus 6 kg per meter square. We need to find out what time would it take for this needle to complete 10 oscillations. इस पूरे needle को 10 oscillation complete करने में कितना time लगेगा? So the idea behind it is fairly simple. We first find out what's the torque due to this magnetic field on this needle, and then using that we finally find out the time period of oscillations. So we know that the torque acting on a needle kept in a magnetic field, if it is displaced by theta from its mean position, is given by mb sin theta, where m is the magnetic moment, b is the magnitude of the magnetic field. Now if I write theta as if I write torque is equals to I alpha, because I know my torque is equals to I alpha, I can get it added equals to m into b, and since theta is very small, my sin theta can approximately be written as theta. So I get my torque, which is equals to I alpha is equals to mb theta. Now my alpha comes out to be mb theta by I. One very important thing to note over here is that this torque is nothing but a restoring torque. So in place of mb sin theta, I can add a negative sign over here, indicating that the torque acting on this magnetic needle is a restoring torque, trying to get the needle back into its original position. So I can replace everything with a negative sign over here, and when comparing these two equations, that is alpha is equals to minus omega square theta, that is the standard equation of simple harmonic motion in terms of angular acceleration, I get my omega to be equals to, if I just compare this, it will be root of mb by I. So we find out the value of omega is equals to root of mb by I. Now we first need to find out first the time period of oscillations, and that can be given by 2 pi by omega, which would turn out to be 2 pi into root of I over mb. So this is the time period of oscillations for one oscillation of this needle kept in the magnetic field. We need to find out the time for 10 complete oscillations, and that time would be nothing but 10 into the value which we found out in the first part, that is this is equation 1. Now when I replace the values of all these, not only replace, when I put the values of I, m and b in this particular equation and multiply it by 10, I get the final value of time period of 10 such oscillation equals to 6.65 seconds. So in order to solve this particular question, what I first did was to find out the torque, put that torque is equals to I alpha, write alpha in terms of mb theta and I, and then compare that alpha to the standard equation in order to get my omega. Once I get my omega, I find my time period of oscillations. After doing that, I'll just multiply that time period of oscillations into 10, because we have been asked to find the time period for 10 complete oscillations. And after doing that, I get my value of time to be 6.65 seconds. So I hope you were able to understand this solution. If you really like this solution, please subscribe to our channel and please stay tuned for much more video solutions coming your way.